Okay, Roy, where's those assignments? You got 2 to get in.
Did they not go through?
I've got, no.
Okay. I'll try again after this class to send them in.
Okay. No. You haven't looked at your physics one yet either. So you've got that assignment 6, chapter 6, chapter 7, and that physics one to get done, Rory.
Full house today.
Yeah, I'll give him 2 more minutes, and then you and I can get some work done together. It's just the 2 of us.
Okay.
We gotta.
Can you go over question 3B, actually?
Yep. Y equals 2 log x to the base 8 plus 4. Yeah. Okay. All right, so I've got 2 as my A, B is 1, C is 0, D is 4, right? Okay. So your key coordinate, of course, is that 1 and 0 coordinate. Now, if I put 8 in for x, all right, I'm going to get the log of 8 to the base 8, which is 1. 1 times 2 is 2. 2 plus 4 is 6. So the other coordinate I could focus on is 8 and 6. All right?
Yeah.
Okay, so now let's just move these 2. So we'll set up a table. I don't need to go through all this, but I'm going to show it to you anyways. So let's go through this. I've got x, y, a, and d really is all I've got to worry about. So 1 and 0, and 8 and 6. Okay, so because of a, I multiply my y values by 2, so that stays as 1 and 0. This guy becomes 8 and 12. Right?
Yes.
Okay, and then I have to move them up 4. So this guy becomes 1 and 4, and this guy becomes 8 and 16. So if those were the coordinates I was focused on. So let's look at the 1 and 0 one. So I move it to 1 and 4. So that's right here. My asymptote doesn't move because it can only move if I change the x value at all, and I didn't. So now it's going to be like this. All right? And the x-intercept, if I look at this and I wanted to solve for the x-intercept, I'd go 0 is equal to so I get -2 equals log x to the base 8. You follow me so far, Rory?
Yeah.
Subtract 4, divide by 2, right? and then I would get x is equal to 8 to the negative 2. So your x-intercept would be 1/64 there.
Okay.
So this is the only other thing that's more or less important, is if you can get your intercepts, whether they be x and y. All right? But that's the entire question. So I have done it kind of in this guy right here or this guy right here. You can use either or to get that to work.
Okay.
Okay?
Yeah.
What about the other three in that question? Like, because those are all the main ones.
Pardon?
What about the other three? Were you able to get A, C, and D, or you didn't try C and D?
Sorry, I never heard you. Dad's on the phone.
Okay. Let's look at C, and let's just do our A, B, C, D for C. Okay?
Let's look. What, sorry?
3C.
3C?
Okay?
Okay.
So my A is what?
-1.
What is B?
1.
Yeah. C?
1 again.
And D? -2. Okay, so this is what I have. All right. Now, so if I'm looking at 1 and 0, all right,
Yeah.
this stays as 1 and 0, but my graph, I have to remember my graph is going to flip. C moves it right 1. D moves it down 2. So there's that coordinate. Okay, so I'm going to look at one more coordinate. And that is when x is 6. Six and -3. Okay?
Okay.
So that's going to become 6 and 3. And then 7 and 3. And then 7 and 1.
So would either one work, or do I want to use both?
Either one works.
Okay.
Okay? So this graph is going to look like this. It's going to... So
Yeah.
now you're going to flip it right away because of the -1 on the A.
Negative. Yeah.
Like that. Okay? And then you'll end up having to move your intercept over as well. 2 to the right, or 1 to the right, I mean. So everything would slide over 1, down 2 at that point.
Okay.
Okay?
Yep.
All right. Any other questions on there?
Not right now. That's about as far as I got. I'm on question 4 right now.
Okay. All right, well, let's give you the rest of today to do that. I want to see that get finished. And then I'll do the laws. I'll do the laws of logarithms tomorrow.
Okay.
All right. And actually, you know what? I'm going to introduce the laws here just because I'm on YouTube. So you can mute and follow along. Okay? All right, so the laws of logarithm, we did these again in applied, and we want to be able to write as singular logarithms so that we can then convert them to exponential in order to solve for equations. Okay, so looking at all my logarithm rules. So again, they all come from exponent rules. So for example, a squared times a to the fifth. We add the exponents together. All right, so we know that one. A to the fifth divided by a to the second. We subtract the exponents. So we get that. A squared to the cube, a to the sixth. We multiply the exponents together. And let's start right there. So when it comes to logarithms, when I have the log of m to the base b plus the log of n to the base b, I multiply those together, so I get the log of m times n to the base b. When I take the log of m to the base b, subtract the log of n to the base b, that's the same as the log of m over n to the base b. So the first two rules are very similar to these two. This one, I add them. Well, when I have multiplying, I separate them into singular logs and I multiply them, I add them. This one, I divide, I subtract. So the rules are the same. This one's a slight bit different. So if I have m to the n base b, I take the n, we already talked about it in this unit, and I move it to the front. So that gives me n times log m to the base b. All right? Another one of the important ones that we've talked about. When you have the log of m to the base m, it's always equal to 1. And what's the other guy here? Missing one. I think that's it for now. Okay, so just going to get rid of my exponent ones here now. Okay, so the first is the product log rule, the second is the quotient log rule, and the third is the power log rule for the three logs. This log rule is just for a common base. Okay, and again, our goal is to, our rationale or our reasons why we do this is we want to be able to, if I've got something, where do I want to show this? Let's say I had the log of x, base b, subtract, or sorry, base 2, let's say. Log of 4 to the base 2 is equal to 5, let's say. And I want to solve for x in this case. Okay, so the way I've got it written right now, I can't very easily solve for x. So what I do is I use my quotient rule. So that means that this is the log of x over 4 to the base 2 is equal to 5. Now that I have it written as a singular logarithm, I go x over 4 equals 2 to the 5th. X is equal to 32 times 4. X is equal to 128. So I'm able to solve for this. Okay, now we're not here yet, but this is why I want to know my rules, so that I can solve for a logarithm by changing it into an exponential question in order to then solve for that there. So basically the 8.3 is you're going to need to use your log rules just to write them as expanded form and singular form. So in working example 1, we're using the expanded form of this. So it asks you to expand this out. So basically what I do is if it's on top, it's adding. If it's on the bottom, it's subtracting. So I have the log of x cubed base 4 plus the log of y base 4, subtract the log of 4 to the base 4, subtract the log of z to the base 4. Okay, and then at this point I need to simplify if I can. Well, I can move that 3 to the front. So I get 3 log x base 4 plus log y base 4. That is 1. Log of 4 to the base 4. Subtract the log of z to the base 4. So there's your expanded form of this. If it's on top of in the numerator position, all right, I'm adding them. If it's down below, I have to subtract both of them. And then at that point, I try and simplify the rest of the solution. Okay, so now let's look at B. Okay, so B, I can rewrite this as log base 5 x y cubed to the 1/2. All right, we got to remember that. So again, we are applying log rules that we learned in applied. We're applying exponent rules that we learned in grade 11. We're applying radicals now, changing those to exponents. We're applying a lot of the math that we've done up to this point. So I move that 1/2 to the front, and I'm going to end up with 1/2 log x base 5 plus 1/2 log y cubed to the base 5. Well, I still have this here. I have to multiply it to the front, or put it down in the front and multiply it by 1/2. So I get 1/2 log x base 5 plus 3/2 log y to the base 5. What we're going to find is that these are going to be much more complicated than what we did in the applied course. We've added rooted values in there, so we have to change those to the exponents, and we have to expand much greater. Okay? So let's look at the last one then. C. So I've got a log 100. Cube root x to the 4th y squared. Okay, now I'm going to break this down a little bit quicker than what I would expect you to. All right, so I'm going to go log 100 plus, that becomes the log of x to the 4/3 minus the log of y squared. Now again, one thing that I didn't point out earlier, and I have to point out now, is if there is no base written, it is known to be 10. So this is in a base 10. So if you look at log 100, look at log 100, that's 10 squared. All right, plus this will be 4/3 log x minus 2 log y. So I move this to the front and put that 2 out there, and I'm left with log 10. Well, that's log of 10 to the base 10, which is 1. So 1 times 2 is 2. 4/3 log x minus 2 log y. So again, much more complicated than the ones that we did in the applied course, for sure. And then the second part of this, so again, I'm going through it fairly quickly because we have done some of this. The second part of this is to go backwards. Make them single logs from expanded form. So I have log okay. So the easiest way to do this is I write log base 2 and I put a line. If it's a positive value, like if it's an adding, I'm going to put it on the top. If it's subtracting, I put it on the bottom. So for this one, I'm going to get x cubed on top. This becomes x to the 4th on the bottom and x to the 1/2 on the bottom. When I write them as singular logarithms, I want to make sure that I use that big bracket here. All right, so that you don't make errors after this. Okay, if you leave the brackets out, it sometimes can look like you are taking the log of this, but not that. So we always leave those brackets in there. Now I have x's across the board here. So I have the log of x cubed over x to the, and I got to add those together. So that's 9/2, all to the base 2. Subtract those exponents. So I'm going to end up with the log of base 2. And it's going to be 3 subtract 9/2 is 6 subtract 9/2. This is actually going to end up, this will be an interesting one. This is going to end up being x to the -3/2. Now I could make it positive if I wanted to, based on my other rule, by putting it like this. I could do that. I don't necessarily need to. I don't know where the book is going to finish that off as. Yeah, they do put it as log of 1 over x to the 3/2. Okay, so there would be my final solution. Again, these are just to improve your ability to change from single logs to expanded form and expanded to single. All right, and the reason that we're going to do that is so that we can, if we can then solve for x values if they are in the logarithmic form. All right. We'll look at working example 3. So I only did A and 2, but we'll look at example 3A. So it says evaluate the expressions. All right. So to evaluate these expressions, if they're expanded, I'm going to make them into single. So I'm going to change this to the log of 8 times 32 to the base 4. Okay. So that's 16,256. So now I'm going to change this to the log of base 4, 4 to the power of, is that 4 or 5, I think. Move that to the front, and the answer in this question is 5. All right, so I'm going to get log of 4 to the base 5, move the 5 to the front. Log of 4 to the base 4 is 1. 1 times 5 is 5. So this whole expression, if I write it as a singular logarithmic function, I can get it all the way down to equaling 5 in this case. All right, so that is 8.3. It's necessary for us to get through 8.2. for tomorrow and get started on 8.3. We have quite a bit left to get through here. So we need to make sure that we're working on it. Okay, that's it for Precalculus. Rory, I'm going to shut the YouTube down and then we'll go through physics.